Okay, hey y'all. So what we want to do in this video is we kind of want to do a little bit of a development sprint here, where our goal is going to be to create an NFT contract that allows us to define what we're going to call a Mint Pass token. So this is going to be a token contract that where anybody that owns a token within this contract will have the right to mint another token in a different contract. So think of it as like basically like an access pass to be able to mint another token. So it's going to have pretty much all the same properties of a lot of other NFT contracts. We're going to probably make this one an 1155 because we're going to have one really identical token that's going to have many copies of itself. So that kind of yields well for an 1155 token. It also would allow us to create one contract that can hold many different mint passes. So we can, have one basically token contract for our mint passes for X amount of projects. So it could be really useful. So I'm going to see how far we get with this. I'm going to kind of try to time box this within, say, a half hour or so, and see how far we get. So I'm here. It's going to be all back end. I'm going to do no front end. We're not going to be talking about any metadata or associating any real media to these tokens. I just want to get a framework in place to be able to prove out that we can create this type of Mint Pass infrastructure. So I'm going to go ahead and create a new project here, and I'll create a directory. Call it Mint Pass, and we'll go into our Mint Pass. Now I'm going to go ahead and just initialize this with npm. We'll go ahead and keep this simple for now, and we're going to go ahead and install OpenZeppelin. Actually, no, I'm sorry. We're going to install hardhat first. Hardhat is going to be the Ethereum tool set that we're going to use. That includes a lot of useful tools for us to create our contracts, test our contracts, compile our contracts. It manages bringing down the Solidity compiler and all that type of stuff. So we got that in place. Now we should see just in node modules package.json. Now what we could do is we could just say nvm hardhat, and not nvm. npx hardhat, npx hardhat, and we're going to create a sample project. We'll let this kind of do its thing for us. This is going to lay out a little bit of scaffolding for us for our project. So it'll create like the directory structure, a test folder, a contracts folder, and all that type of stuff. And once that's done, we're going to want to bring in OpenZeppelin. Zeppelin. What is it called on npm? What is? Oh, is it at OpenZeppelin? No, what am I doing wrong here? So we're going to go ahead and say Zeppelin. It's OpenZeppelin contracts. I gotcha. Okay. We won't use the upgradable contracts for now. We'll just use the regular contracts. Okay, so now we should have a nice little directory structure here, and we should actually have a test contract there that we can pass. It comes with a little a greeter contract that we can go ahead and test. So there we go. We're compiling a smart contract, and we have OpenZeppelin. Let's go ahead and open up VS Code. Now the first thing we're going to want to do is define an 1155 contract that's going to represent the Mint Pass. So we'll go into our contracts, and I won't remove the greeter just yet. We're just going to create a new file, and we're going to call it mintpass.sol. And we'll go ahead and Is that how we typically do it? I always forget. Ah, it's the license identifier. So we'll put the license identifier in there. We'll put the typical stuff here that you would normally include in a smart contract. All right, and then let's go ahead and define our contract. We do want to include the Open Zeppelin. So at Open Zeppelin token, contracts token, ERC 1155, 1155. And then we're going to go ahead and define our contract. So we'll say Mint Pass is, boom. Oh, gotta spell contract correctly, huh? Contract. Mint Pass is 1155. We do need a semicolon here. And there we go. So this, we have a little mint function here, ID, amount, and we're going to probably want to call the internal mint function here, not this, right? There's going to be an internal mint function. And okay, we don't want it to be abstract, so we'll have to have a constructor. And we'll have an owner. Actually, you know what? Why don't we do this? Instead of just having just a regular owner, why don't we make this ownable so we can actually support the ownable interface here. So we'll go ahead and import Open Zeppelin contracts. And where is that in the contracts? Let's see. We go here, Open Zeppelin. Probably in access, right? Ownable. Contracts, access, ownable. And then we're going to say is ownable. Okay. Is that what you want us to do here? What is this complaining about? Contract Mint Pass should be marked as abstract. Why? Why should it be marked as abstract? Owner. 3 arguments, but 4. So let's go ahead and open up the 1155 base contract that we're going off of here. All right, so this is and there should be I believe there is a mint. Yeah, so we have a toID amount and any data that we want to pass into it. So we don't want to actually pass any data into it. So I think we could just pass in nothing. And that should work. Now, why is this not liking this, but it likes this? Okay, so I guess for now, that doesn't really matter. We'll just make an owner here. What are you complaining about? Why? Mint Pass should be marked as abstract. Why? Why? Well, let's see. Let's go to Googs. Okay, so I guess I need to call into the constructor here. So this constructor needs to call into, and the way that you call into constructors in Solidity is a little weird, I find, where you kind of like call it right after here. So we go ahead and say ERC 1155, and then pass in what we need in this constructor. So the constructor here, let's see what that takes. It's just going to take a URI. So here we'll give it some, fake URI or something. We'll just say, IPFS test or whatever. It wants to make it abstract. Okay, so I don't think we need to do that right now. So we'll make this, and you know what? We don't even need to pass in the owner. We could just say whoever creates this. So we'll say message.sender is the owner, and that should be fine. Okay, so now we should have the ability to actually mint 1155 tokens and a quantity of them. So let's see if that actually works. What we'll do is let's go to our test folder, and we'll go ahead and let's grab this test just to get the framework of it, and we'll say Mint Pass test.js. Let's put this in here. This gives us chai, this gives us hardhat, and we're going to describe our Mint Pass, and it should allow for minting of 1155 tokens. And we're going to say the Mint Pass is equal to Mint Pass, and then the Mint Pass, the actual instance of it, will be a deployed Mint Pass, and we don't need to pass in anything here. And now the Mint Pass will be deployed. So now what we can do is we can simply run this without any assertions, just to make sure that we can actually run it. So let's see. Okay, so that didn't fail. It's still giving us this, if you want the contract to be non-deployable, making it abstract is sufficient. Not really sure what that means, guys. So let's see if there's a quick explanation. This is saying that that adding public, a visibility specifier, to a constructor has no effect. Constructors are only run once when the contract is initially deployed. They can't be called at a later time, so aren't visible in the sense that variables and functions are. Abstract contracts don't have constructor. So the error is basically saying you've incorrectly used a visibility specifier on the constructor. Did you even mean to use a constructor in the first place, or did you intend to write an abstract contract? So I guess just taking the public away will do it then, right? There we go. Okay. Gotcha. So that makes sense. So basically, because the constructor is only called once, making it public, and it's really not part of the instance of the Mint Pass, right? It's called once we instantiate a Mint Pass, once we create it, but it doesn't stick around and be like, hey, I'm a public method that you can call and do stuff with. So not having public there makes sense. Awesome. We're learning, guys. We are learning. So let's go ahead and now let's see if we can actually call the mint method of this Mint Pass, right? So now we should have this Mint Pass, and we're going to go ahead and say mintpass.mint, and we're going to mint to the first address of some specified ID that we could just create ourselves and some amount. So we'll go ahead and say we're going to mint to, and we have to get the signers, right? So in order for this to work, we have to do something like this, right? No. What did we do? Let me take a look at what I did in a previous project. In the beginning of this, I could have just done ahead on this. We created the token. Yeah, this accounts that get signers. So this is really what we need. We need to be able to get the accounts that we're working with. So what hardhat does is it uses a local blockchain called Waffle that enables us to test out our contracts. So what this is doing here is it's just saying, hey, we're going to go ahead and get the accounts that we're working with. So this way we could do something like this. When we call mint, we could say this.accounts sub 0, and we'll go ahead and mint token ID 1, and we'll mint 1,000 of them. And now I'm just curious if I just do a console log token just to see what this is going to return. Which we don't have a return value on here at all, so I don't think it's going to return anything, but let's see what happens. Oh, okay, so I think we need to put dot address here. There we go. So what we did was we have a transaction hash here. So we have this transaction. And now I think what we can do is we're minting to this account in order to verify that we actually minted this token, right? Because this is going to be a transaction, right? So we can call it TX. Now we can await the transaction, but I think we kind of are here, but we can put some callbacks on this transaction, or we can call back into the Mint Pass, and I believe the 1155 has a balance of. So we can call this balance of, and it will return the balance of a given ID for a given account. So let's go ahead and in our test, let's say, all right, now let's read the balance for account 0 for token 1. So we're going to go ahead and say, boom, Mint Pass balance of. There we go. And now what we should get, and I'll do an assertion in a minute, but if we say balance, now that's going to return a big number. It's going to be an object that represents an unsigned large integer. So we'll go ahead and say toString here. So this will bring it back to a string so we can output it, and let's see what it outputs here. There we go. We should get 1,000. So what we could do here is we can maybe call this twice. So let's call this before. So we'll say balance before, and then we'll say balance after, right? And now we'll do some assertions here. So we're going to say expect balance before to number to equal 0. And then we're going to do the same exact thing here, but it's not going to equal 0. We're going to expect it to equal 1,000. Now let's run those tests and expect 0 to equal 1,000. Balance before, balance of address 1 equals 0. Balance, oh, because I said balance before here. We got to say balance after. There we go. So now we are able to mint tokens into this contract using 1155. Simple as that. So now, obviously, there's a lot more to this in terms of getting metadata associated with it. Basically having your URI set up properly and being able to grab the metadata. But we don't really need to be concerned about that right now. We're more concerned about being able to take now this token, implement another token. So we're going to do the same exact thing, but we're going to do it with a 721, and then we're going to reference the 721 to the Mint Pass contract, and then have a mint function that validates that the caller is in fact an owner of the Mint Pass before we actually mint the token. You following me, guys? Awesome. All right, let's roll. So now let's go ahead and create, and I'm going to get rid of this greeter token now. So we'll get rid of this guy, and we'll get rid of the sample test here. We don't need that anymore. Okay, so we're going to go ahead and create a new file, and we're going to say it's a NFT drop.sol, right? Now this drop represents an NFT contract that you are going to need to hold a Mint Pass to be able to do it. Now there's a couple of interesting things I think that are going to arise here. So let's go ahead and we could basically just copy this, right? It's basically the same, but we're going to make this a 721. We could technically make it 1155 too. It doesn't really matter. I'll make it a 721. It actually might make it a little easier. So if we go 721 here, now we'll call in the constructor 721. And now the 721 needs a little bit more information when we construct it than just the IPFS or the some data. So we have to give it the name. We have to give it our symbol, and I think that might be it. Wait, did that public? Interesting. Okay. Okay, so we don't want to be able to. So Mint is just going to take. Let's take a look at that contract again. Let's go into Open Zeppelin contracts. We'll go into 721. And now when we construct it, we have the name and the symbol, so that's correct. And let's take a look at the internal Mint function. So that's going to be, we have the safe Mint function, which we have to token ID and data, right? So we'll use the safe Mint function. And we'll just allow, does this use the safe Mint? No, this calls Mint. Okay, yeah, so we'll go ahead and use the safe Mint function. So we'll go here and we'll say safe Mint to ID and amount, and we do need some data here, to token ID. Oh, we don't need amount because amount is that's 1155. So we're going to just pass in some blank data there. We don't need the amount parameter in the Mint method. And we'll call this method Mint with Pass, right? Because now we have a 721, and we're going to call this not Mint Pass, but NFT drop. And what we'll do is we'll put this all in the same test because we're going to have to associate them. So we're going to write another test here, and we're going to say it, whoops. We're going to say it should allow for minting of 721 tokens. Now, the first thing we're going to do is basically just try to get the same kind of flow that we did up above. Basically, I'll copy this, bring this here, and we're going to say the NFT drop. All right, we'll go NFT drop. And we'll call this NFT drop. Right? Now it's going to be a little different here because we don't need to do this balance before and stuff like that. So we're just going to call the mint, and we will call balance of, but I don't think it may be a little bit different. So we're going to say mint with pass, right? That's what we called it. 2 with an ID. So mint with pass, 2 with an ID in our test. And this is one of the reasons why I really like smart contract development, because in order to run the programs while you're developing, you need to write tests. You can't, it's very hard to bypass the requirement of writing tests. And in other development environments, it's relatively easy to bypass writing tests, and that could get you into trouble a lot. So we're going to say mint with pass, and we don't need that. We're going to just mint token ID number 1. And that should be it. So now in our 721 contract, let's just go ahead and pull that bad boy up again. And let's see, we go to token 721, utilities. Oh, not utilities. What am I doing? 721. And I believe there is a balance of in this as well, right? So balance of owner, and this will just return a balance, right? So we don't pass in a token ID. We just say, hey, what's the balance for this user on this contract? How many tokens in this contract does the user own? So basically do the same thing. So we're going to say mint with pass, balance of, and we don't need to pass in the token ID, and we can go ahead and we could just call this balance now. And we should expect it to equal 1 after we execute this. So let's see if this is working now. Go ahead and run our tests. Boom. All right. So we are now minting 1155 tokens and we're minting 721 tokens. Now is when the fun starts. Now we need to be able to associate the two contracts together. So we need to be able to check the 1155 for a specific balance before we actually allow the minting of the 721. So how are we going to do this? The first thing is we need to know the address of the 1155 within the 721. So we can do this when if we did this in kind of a segmented kind of phase where we deployed the Mint Pass and then we knew the address of the Mint Pass, we can then mint or deploy the NFT contract with the Mint Pass address coded into it. So we could say, Mint Pass address equals, some address, right? And then we can use that address and wrap it in the interface of an 1155 and then be able to call into its methods. But we don't know the address as we're testing. So what we're going to do here is, and if anybody's watching this, definitely open in the comments for ways to do this better. But what I'm going to do is I'm going to go ahead and write a method that we'll be able to call. And now I'm going to make this a little insecure just for simplicity's sake. Actually, no, we could do it like this. Yeah, we could do this. So this is we're going to say require message sender equals owner. So we will secure this a bit, and we're going to say set token Mint Pass address. Right? We'll say set Mint Pass address, and we'll pass into it a token address. Right? And now we'll say address. Token address will be a property on this contract. And then we're going to just go ahead and as long as the message sender is in fact the owner, which we set up in the constructor, we're going to say that the token address is equal to token address. Awesome. So now, just complaining about. I got to spell things correctly. All right, token address. There we go. So now that we have the token address, what we can do is we can actually wrap it in the interface of the 1155. So if you look in the Open Zeppelin contracts here, you'll see that we have not only implementations, but also interface files for the given standards. Now the interface files, they do not implement any of the methods. They just kind of include a library of function signatures, right? This is a basic kind of interface in object-oriented programming. So what we're going to do here is we need to include that here. So we're going to go ahead and import that into this contract. We're going to say we need the 1155, and we're going to say I1155. Right? Now within the Mint Pass, we're going to go ahead and instance an 1155 at the token address. Boom. So now the token is going to be wrapped in this 1155 interface, and we're declaring this token, right? So now with that in place, we can now check the token check to ensure token 1 in the token contract is owned by the caller. Right? Boom. So we're going to say, and this is pretty interesting. I'm using Copilot right now, so I'm kind of testing out some of the Copilot functionality. And I find as I do this more in practice, it just gets better and better at like basically figuring out what I want to do, which is insanely kind of mind-blowing. So we're saying here we're going to require that the token balance of the message sender of token 1 is equal to 1. Now we could say greater than 1, but we'll say, yeah, let's say greater than 1. Greater than or equal to 1. So a user can have, multiple mint passes and still be able to mint. That's fine. So now I think that's all we need, right? So if we have the ability to set the mint pass, let's go ahead and write a getter too, just to be able to test it. So we're going to say function get mint pass address, and we're just going to return the token address. That's all. So let's go ahead and now go to our test here. Now we are able to mint these. Now what I want to do here is let's go ahead and let's just refactor this test a little bit. We're going to move some of the instantiation, the actual, the initialization of these contracts into the before section of these tests. So this way we don't have to keep doing this as we write more tests. So we've got these two deployed, and I'm pretty sure that we can get the address of this very easily. So let's just make sure of that. So I'm going to go here and say, what are you doing? So it should allow minting only if, actually we should just test, it should allow setting and getting the mint pass address, and probably say NFT drop should allow setting and getting a mint pass address, right? Good. So that is looking good. Now these, I got a question. You think these tests are going to fail right now, or do you think they're going to pass? Make that a little bit bigger. I probably should have done that in the beginning, but now they should technically fail, right? Because here we're minting and we're saying mint with pass, but now users don't have, oh, actually, no, I might be wrong because we minted up here. So the user is going to have 1,000 of these. So let's see, this actually might pass. No, because we never set the address. So it's going to fail, right? And we also have some type of syntax error here. So what did we do wrong here? Right, okay. So let's run that again because that was just an error in the, right, okay, cool. So also, because we refactored this, I think we need to do, we need to do this dot, right? What did I do in the other project? Yeah, the deploys I did at this dot. So we made it, yeah, so here, we'll say this dot mint pass, and this just gives us access to this across the test suite, right? So now we're able to access this across the test suite, and basically anywhere we have the NFT drop here or the mint pass, we're going to say this dot mint pass, the NFT drop, say this dot NFT drop. Okay. Let's see if we get that same error. So we still are referencing mint pass online 10. Okay. Function call is not a contract account. It's a non-contract account. Okay, so that's good. So we're now getting this. We're saying, hey, we're trying to reference another contract, but we never set that address. So we need to set the address. So now I think what we can do here is, now that this is deployed in this before, if I say console.log this.mintpass address, we should see an address here. Yes, we do. There we go. So that's the address we want to set within the NFT contract. And we can go ahead and do that. We probably should do that first. So let's go ahead and take this and say, here, it should allow setting and getting a Mint Pass address. So what we're going to do is we're going to say this .nft drop .set Mint Pass address, and we're going to set it to this .mint pass address, right? And then what we'll do is we'll say we'll get the Mint Pass address, and then we're going to say expect the Mint Pass address to equal to the address we just set. So we're just kind of working out those methods to make sure that we can set and get the Mint Pass address. So let's go ahead and do that. So Mint Pass address is not a function because I don't think we called it that, right? We called it set Mint Pass address. So set Mint Pass address, and then we said get Mint Pass address, right? Okay. Boom, baby. Okay. So we're able to now set and get the Mint Pass address. We don't need to now console to log this anymore because we're verifying that. Now, I think it actually worked, right? So if we're minting this token and then we're minting it here. So now, why don't we do this? Why don't we take this test and just comment it out for a second. Now the user does not have the 1155 token, but we're going to go here and try to mint with this token, and with the 721, and I'm expecting this to fail. Boom. So we're not getting a good error message. It's saying transaction reverted without a reason string, but it worked. So now if we go ahead here and we mint the Mint Pass, boom. There we go. We can even do it another way and say, all right, we're verifying that the user has the token 1 in the 1155 contract. Let's go ahead and not mint token 1. Let's mint token 2. And then we're going to check the balance of token 2 for here. So this test will still pass, but this test will not. So let's see. Boom. Ha! We did it. Excellent. So we have a really basic example on how to develop a Mint Pass contract, really simple, and an NFT contract, a 721 contract that allows us to verify that a user has the balance of the given token before we allow them to mint. Awesome. So I don't know how much time I took there. I'm probably a little over a half hour, but I'm going to stop it here. And hopefully, this is kind of a raw video. I wasn't really very prepared to come into this, so and I kind of wanted it that way. So hopefully this was helpful. And yeah, I definitely learned some stuff here. This was fun. So any improvements, any things that I did wrong here that you guys can see out there, please leave in the comments. Reach out to me. I'd love to continue to learn with you guys. Thanks.